We often like to use ratio tables to help us create more matching ratios. But what if we are given a ratio and we want to see if that table of values is a proportional relationship to the original? Let's look at this problem. It says, which of the following tables represents a proportional relationship between x and y with the ratio of 3 to 4? So that means that x is 3 and y is 4. When we use the variables x and y, we like to make the y be the numerator and the x be the denominator because we are referencing a coordinate plane. But the reason why we're going to set up our ratio this way is because we're going to actually divide to figure out what that relationship is. So we're going to use a calculator to find out what is a 3 to 4 ratio. 4 divided by 3 is equal to 1.3 repeating. So all we want to do is we want to find, does this row also equal the same thing? So we're going to take 8 and we're going to divide it by 6. We find that that is the same value, and so that means that the first row is a proportional relationship with that ratio. What about 7 and 9? So we're going to take 9 and we're going to divide by 7, and that equals 1.285. So that is not correct, and therefore this whole thing is not a proportional relationship to the ratio of 3 to 4. Let's look at this one right here. This one, we're going to take 24 and we're going to divide that by 6, and that equals 4. So that doesn't match at all with 1.3 repeating, so we can move on to the next table. We know that 6, 8 does match, but what about 9.5 and 7.5? So when I type that in, 9.5 divided by 7.5, that does not equal 1.3 repeating, so that is not a proportional table. And then let's look at the last table. We have 8 and 6, or 8 divided by 6, that is proportional. But what about 10 divided by 7.5? That does equal 1.3 repeating. And then how about 12 divided by 9? That also equals 1.3 repeating. So D is the correct answer for this one. On the next one, it says that Sophie makes $12 an hour babysitting. So our ratio is $12 for 1 hour. $12 for 1 hour. It says here that the money she earns is Y, so Y is on top, and the number of hours is X, so X is on the bottom. So when I take 12 divided by 1, that equals 12. So I need to find that my division problem should equal 12 every time. When I see this, it says 12 divided by 2. Well, I know that equals 6, so this is not correct. How about 24 divided by 2? That does equal 12. 36 divided by 3 equals 12, and 48 divided by 4 equals 12. So this table does work. Let's look at this one. 2 divided by 12 is actually an inverse of this one. This is not correct at all. And then also, 2 divided by 24 is not the same as 24 divided by 2. So this is not the same relationship as this.